Object-oriented programming, or OOPS. We are taking question and answer on it. What do you understand by OOP, or object-oriented paradigm? So this OOP, or object-oriented programming or paradigm, this is the full form. So there are various languages, programming languages, which follow this object-oriented paradigm. So these programming languages are called object-oriented programming. So this is a programming paradigm, and that revolves around, that has a pointer, and that pointer is called object. That is, the base is object, not the function, not the procedure, not the methods. The previous structural programming languages, the functional programming languages, all these were basically revolves around the function or procedure. But here, everything is around object. That is why it is object oriented. So everything will be on the basis of object. Basically, the main idea is that real life entity, a real life world has to be mimicked, has to be actually programmed. So object is a real world entity that will contain the data and the code and the functions operating on that code. So this allows binding data and code together. So we have certain concepts and certain baseline concepts which defines an object-oriented programming. The basic is that everything has to be an object. For example, Java, it is not a pure object-oriented paradigm following language, because everything is not an object. So OOPS, or object-oriented programming, is based on four main concepts. The first is abstraction. The second one is polymorphism. Third one is encapsulation. And fourth one is inheritance. In any order you can just remember it. So abstraction is all about creating abstract classes, abstract methods, the interfaces. That is, in certain programming languages there are interfaces, somewhere it is not. Basically what you're doing here is you are creating a class, abstract methods or abstraction you are given, just have to implement. That is, you're not giving the implementation here. Similarly, we are talking about the encapsulation. Whenever we are making a class, what does it mean? It acts like a capsule. In this capsule, we are fitting the variables or the data, or we are filling the functions. This function will be operating on these variables. Along with this, we have the access modifiers, which are default, public, private, protected. Then coming to the polymorphism. Polymorphism can be compile time and runtime. That is one phase doing different acting. For example, a function add can act differently depending upon what kind of input you are giving or what kind of return type it is having. So it can be compile time. When it is at compile time, that is called as method overloading, and when it is at runtime, it is called method overriding. So compile time, method overloading, runtime, method overriding. Then we have the inheritance. As I was saying, that the real world entity, you inherit something from your father, like money, like land or house. So same way, a class, when it is being made, the content can be reused, reusability. So you just have to inherit that class. So the class which is inheriting is called the base class. The above class which is being inherited is called the superclass sometime, or the parent class. So parent-child concept is there. There are different types of inheritance. We have single, multi-level. So this is basically mimicking, all these are mimicking the real world, and that can only be possible with objects. Name any 7 widely used object-oriented programming languages. So the mostly what we are using today is Python and C#, but after C there was all object-oriented programming language. So C++ got very famous. Most of the software still are written in C++, variations of C++, C++11, C++14, like that. So let me name it. Python, Java, Go, Dart, C++, C Sharp, Ruby. So C Sharp related to Microsoft. What is the purpose of using OOPS concepts, object-oriented programming concepts? Why are we using it? Why we are not using other kinds of concepts of programming? So the idea and the aim of OOPS is to implement real world entities, because you are programming for real world. So you need certain kind of concepts. For example, your father is there and you inherit something from him. This is the real life scenario. So in object oriented programming, we can implement it using inheritance. Okay. In structured languages, we have global data and local data and statics data. But here we have the data which is, we can hide them. We don't expose them. We only expose when it is required. A single function can have different faces, polymorphism. So inheritance, hiding, polymorphism, these are the basic building blocks of the object-oriented programming, which is actually mimicking and implementing the real world entities. The main purpose of OOP is these data and function. So the function can work on these data which is being defined in a class. So the other part is not accessible, they are not been exposed to others. For example, if you in structured programming language, you just write main and then you write everything there. You just call the functions. So basically, these the problems which were there in the structural programming languages or the previous programming language, they are tried to be handled in object-oriented programming paradigm concepts. So we have the abstraction. Abstraction is all about creating those classes which cannot be instantiated. It needs to be implemented. Interface also implemented. Then we have the polymorphism. Polymorphism can be, we can overload and override the methods. It can be at compile time, runtime. Then have encapsulation is all about having the data function inside, and we have the class or interface. Inside this we have modifiers, and then inheritance, of course, the parent child concept. So now you can make a vehicle, and now you can make a vehicle and then inherit the car, any kind of Ford or say Chevrolet, etc. And these four things are the basic building blocks. Along with this, you have class and the object. These are very important because class is the main key, main frame whose everything comes to or is given to an object, and an object can do everything which a class has been made for. So that is why we are using OOPS. What are the four main features of object-oriented programming? So the four main features are inheritance, encapsulation, polymorphism, and data abstraction. So these four are very important, and every programming languages which is object oriented should treat everything as an object and should implement the inheritance, encapsulation, polymorphism, and all the code constructs which is given in the programming languages. They are made so that all these concepts can be implemented by a user. Why object-oriented programming is so popular? What is the reason? See, first thing, there is a real world. Now you are making software or program for real world. You are making a website. You are making a mobile application. For whom you are making? You are making for the real people. So there has to be some programming languages to implement the real world scenario. Somebody came to you, he says, make a mobile application for me. So you have to choose a programming language that should implement and provide you all the facilities so that you can make that real life mobile app work. So this real world scenario can only be implemented when you have the underlying constructs and concepts in a programming language, and that is possible in object-oriented programming, object-oriented paradigm. So this OOPS, this is considered as a good or better style of programming. The advantages are quite high than the disadvantages. Not only it helps in writing a complex piece of code quite easily, but also it allows user to handle and maintain them easily as well. So first is complexity is reduced, and maintaining and handling is also easy. Data abstraction, encapsulation, inheritance, polymorphism, all are there. They make it easy for programmers to solve the complex real life scenarios or problems. That is why this OOPS or paradigm or this concept is so popular. Okay, now there are certain things which you need to know. This is following a bottom-up approach. The structural programming languages, they were following the top-down. That is, you have to make a main and then you decide what all functions you have to make. You start from the top and then you come to the bottom. Then you implement these functions. But in object-oriented programming, first you have to plan. Then you have to make the different classes. In this you have data variable, the function working on it. And then you combine these classes to make the whole software or project work. So all the previous programming languages, they were concentrating only on functions. Only on functions, as you see here. Add function, call, and just you make an add function and call it. Subtract, write somewhere, call it. So this was all about functions. There was no thought about data. Object-oriented programming is all about data. In the previous programming language, local data, global data, every data was not even thought of. The data is so important. You are working on data, so you are actually you have to be very careful about the data. But here, the data is the key. We are not the functions are helping hands to operate on these data. So data is used by associated function within the class. That is, you make a class, first you decide about the data and then the function which are going to operate, that is going to work on this data. The security of this language, because you cannot access anything from anywhere. There are public, private, protected constructs, or you can say the access modifiers, specifiers. You have abstraction here. So the security is quite good in terms of data. So we have example like C++, Java, Visual Basic, Python, PHP. These are all popular object-oriented programming languages. What are the advantages and disadvantages of object-oriented programming? Well, there are mostly the advantages, less disadvantages. First thing is, it is a bottom-up approach. It is not following the top-down as the structural programming. The bottom-up approach, that is, you have to first design, first you have to plan what all things have to be done. So then you combine these. That is, you're actually thinking about the lower level of abstraction going to higher level of abstraction. The OOPS, it is modeling the real world well. You have polymorphism, inheritance, encapsulation, data abstraction. All these are because these are the concepts which are there for real world. And since we have this inheritance, what do you write in a class? No, you have the reusability aspect. In inheritance, you can reuse it. So the public-private, I was just about telling that this is to provide the abstraction. Data cannot be exposed everywhere. So object-oriented programming forces the designers, the software designers, to have a long and extensive design phase that result in better design and lower faults or fewer faults. That is, the most of the time is taken in design. If you make a good object-oriented related design, then only you can make a very good real-world life problem solution, and that will be in C++ or Java or PHP, etc. So we decompose a complex problem into smaller problem and then we deal with it. And programmers are able to reach their goals faster. The complexity is less because everything is quite clean and defined. Easy redesign and extension of code that do not affect the other functionality. For example, at the maintenance phase, some changes there. You know that this class and this function is there. What is the cohesion? What is the coupling? And you know it and you can change it. The disadvantages of OOPS, first of all, proper planning is required, proper design is required. You cannot jump to directly programming as you were doing in C language. Program design is quite tricky. You need good designers, understanding of UML, Unified Modeling Language, and the object-oriented programming constructs. Programming should be well skilled. Programmers should be well skilled because you need to know all the programming object-oriented concept. Then only you will be able to do it. And classes tend to be overly generalized. And overly generalized means number of classes, cohesion, coupling, all. There are certain scenarios which are quite cumbersome, and that has been taken care in other languages. What are the limitations of object-oriented programming languages? So there are advantages, so there are disadvantages also. So what are the basic disadvantages? First, in order to write a C++ program or a Java program, you have to do a proper planning. I'm not talking about a Fibonacci or a factorial program. I'm talking about the actual software made in these programming language. Program design is quite tricky and programmer has to be quite skilled, not only in making smaller programs, but the bigger programs, making classes, the objects which is going to instantiate how to make abstract classes, how to perform the overloadings and the runtime and the compile time, method overloading, overriding, etc. The classes tend to be overly generalized. So this generalization of classes all these are a complex thing. So let me talk to this again. It requires intensive testing processes because if the design is so that when you're making a real classes and they are combining, their cohesion coupling is there, intensive testing will be there. Solving problems that take more time as comparable to the procedural oriented programming, because procedural you just go on and make the functions or whatever you want to write, but here not. The size of the program will eventually be higher as compared to using the procedure oriented or structured programming language. The line of code or kiloline of code will be higher. Software developed using this approach, it requires a significant amount of designing, pre-work, planning, analysis, etc. So if you do not have the class documentation, object-oriented programming code is somewhat difficult to understand. If you are not experienced, it may create problem. In certain scenarios, the program may consume large amount of the memory, and for small programs, OOPS is a no-no. Takes more time to solve problems. For example, C is a faster language. Still the embedded software are written in C till now. But C++ takes more time than that. What are the differences between object-oriented programming and structural programming? The structural programming is all about functions. If you have worked on C, it's all about functions. If you have worked on C++, Java, it's all about the data. Okay. First of all, object-oriented programming and structural programming. Structural programming follows the top-down approach. That is, first you decide the main functionality, then you see, okay, what all small things we need. You make different functions for that. Object-oriented programming is a bottom-up. First you decide what you have to do at a lower level, like you make classes and then you combine them, collaborate them, interface them. The object-oriented programming, it provides you data hiding. You have private, protected, different access modifiers and specifiers. In structured programming, data hiding is not there. The least you can do is to make global and local. This is what you can do, or static for at the most. But in object-oriented programming, you have data hiding. In object-oriented, we have the solution to the complex problems, because it is implementing the real world scenario. Structural programming, moderate to easier kind of problems can be solved. Structural programming, complex structural programming is not good. See, object oriented programming is giving you inheritance, and there are other all concepts. So it allows reusability of code, that reduces the redundancy of code. You don't have to write again and again. Make a class or make a component and you can just use it again and again. Reusability is good, or it provides the object oriented OOPS provides it. Structural, no. Reusability, you have to write it again and again. In OOPS, it is based on objects. The basic is object. A class you make and then you create as many objects you want. It is based on objects rather than functions or procedure. Structural programming, it provides a logical structure to a program in which the program is divided into functions. Or you can just say that the structural programming is revolving around only the functions, procedures, or the method. It has no concern about object or the data, because there is no concept of object there. In OOPS, it provides more security as it has data hiding feature, as I just suggested. Data hiding is there. In structural programming, no data hiding. Everything is exposed. The data is exposed. Anyone can use it. Any class, any different file can use it. So object-oriented programming, data-oriented, structural programming, function-oriented. So first we write the data, then we write the function who are going to work on it. Are going to actually implement or interact with this data. In structural, it is on the functions. Data has no concern. Function is basis. What do you understand by pure object-oriented language? Why Java is not a pure object-oriented programming language? So in order to answer this question, the one thing is, any programming language which deals only with objects, that is pure, otherwise it is impure. So a programming language is called pure object oriented language that treats everything inside the program as an object. There cannot be any kind of, say, predefined data types or user defined data types. Everything has to be an object. So the primitive types are not supported by pure object-oriented programming languages. No primitive, no predefined. Okay. So there are some other features that must be satisfied by a pure object-oriented language. Of course, every programming language has to do. There are certain programming languages which are just 90 or 95% object-oriented, but we can deal with them. But for example, the PHP or Python, you can say that they hold that OOPS power. In encapsulation, inheritance, polymorphism, abstraction, these are there, but all predefined types are objects, all user defined types are objects, all operation performed on object must be only through objects exposed to the objects. Methods which are objects exposed only by the objects. Java is not a pure object-oriented programming language because predefined data types in Java are not treated as objects. Therefore, it is not an object-oriented language. Now you have to tell me what all languages are not pure object-oriented language and which are impure, which are pure. So class, actually object-oriented programming has come from object. So everything is object in object-oriented programming. But object comes from class. First you make a class and then the instance of the class is the object. So class is nothing but a blueprint, a framework, or a template for an object. So in order to make an object, you have to make a class, and then you can make multiple objects from single class. So these are number of objects which you can create. Since you are making this class, it is a user defined data type. It is a user defined because you are the maker of the class. Inside a class, what we do, let us say I'm making a class, my class. So in this class, we define certain variables. It can be integer, it can be float, it can be different data type. Then can be constants. Then the operations or the methods or the function, whichever way you call it. And these function will operate on these variables. And there are other functionalities also. Please remember, class will not take any memory at runtime. Class, no memory at all at runtime. Okay. Class is not a data structure. Class is not a data structure. It is just a conceptual logical entity. Class is just a logical entity. When we create the object, then memory comes. So when you are encapsulating, see, variable and function are there, so it is called a binding. It does the data binding. Now coming to object. Now when I created this class, I can make now the object. I can use the blueprint and template, and now I can create the objects. So object is actual, what we are talking about is a real world entity. That is, it is mimicking or it is presenting the actual real world entity that will have attributes. For example, a class car has certain attributes, properties, methods, but this is just a class. But when you actually do it using an object, when you create a object of a class, then becomes the property of say an Audi, method of an Audi, variable of an Audi. So it is referred to as an instance of the class. It contains the variables, the functions, what we have defined in a class. So this object will call that function. This object will call this variable, or you can say access the variable. So object has all the power. Class is just a blueprint or a template. So class does not consume any memory, but object occupies space in the memory. Object takes place in the memory. Different objects, they may have different states or attributes or behavior, because you can make innumerable objects. What are the differences between class and object? A class is a template, is a blueprint to make an object. A class, it is just a blueprint. So when you make a class, it doesn't take any memory at runtime. For example, I'm making a class car. You put certain variables, some constant, the functions operating on these data variables or data. So this is a binding also. It is just a template which will give us the possibility of using this template with respect to by means of object. So now this car was the class, but I made a Ford name object, a Toyota name object. So now the object is being created. So class is just a logical entity, just conceptual entity. The real world entity which you are going to deal in your programming, which you are deal in your paradigm of object oriented, is object only. A class shows that this is the data, this is the variable. But actual usage comes when you create an object for that class. So this is a real world entity. For that you have to make a class, of course. So as I said, class is a concept, like structures, like all these shows you, because it is not a data structure. Class is not a data structure. That is why we are calling it as just a template or a logical entity or conceptual. But the objects are real. When you create an object, then you start accessing the variables, the data, and working on the data with respect to or with the help of the functions. So it is real. Object is real. Class, if you see here, we have data, we have functions which are operating on this data. So class is binding the data and method together in a single unit. So this is a good way of understanding the encapsulation also. Good way of understanding the abstractions also. But object is just like a variable. like int x, integer x, this is the variable you make normally. So int here is the class which is the user defined say you can entity, and x is a variable of type int. So here we have the object which is of the type of class. So Ford is an object of type car. As I said, class does not occupy space in memory. Object, when we instantiate, when we make an object, then the object will occupy space in memory. Class, just a template, no memory at all. Class, it is a data type, and this is a user defined data type. Please remember that it is just giving a blueprint or a template for object to be made. So you cannot call it as a data structure class. You cannot call it as a any other kind of data type. It is a simple user defined data type. But the object is actual instance of the class. The class you just have to declare once. Make a class one time, and then you can create millions of objects. These millions of objects can be declared and used as and when required. The objects are only limited by the memory and resources. We use the class keyword to make a class. This is a class, you see, CLASS, class, to make a class. This is a keyword we use. Most of the OOPS languages, they provide this. Some of them does not. So this is the keyword class we use. And what we do in the object, it uses a new keyword to create an object. So new is all about, new gives memory, allocates memory. Like we do malloc, calloc in C. So we use new to create an object. New is by itself is a memory creation. So that is why I am saying when we make an object using new, then only we actually allocate a memory for an object and we start using it. So C++ we use new for memory creation, delete for memory liberation. Okay, class can exist without any object. If you make only class and no objects, it doesn't matter. That is what the abstract classes etc. are. But the objects cannot exist without a class. If you are not making an object, the class, you cannot make an object. So it is not by itself. What are the key differences between class and structure? See, in C, structure was so helpful because the different kind of data type variables can be placed there, and then you can just use as a variable, just make a variable of structure and then start using it using the dot operator. See, the class also works like that. You know, you make a class and then with dot operator or any operator of the programming language, you can just call the variables and the functions. So class is a blueprint. It's just a template from which objects are made. So if we are making a class, say car, this class, we have certain variables we have declared and we have some functions we have declared, and class is a group of common objects that share certain common properties. So when we make the object of this car, that is the class, the Ford and Toyota, these are the objects, and they are sharing a common property which is defined in your template or a blueprint, which is called a class. So in a class, whatever is defined, that property is now, when the object is instantiated, it has. The structure is just a collection of different data types. It has no functions. We have int, we have float, double, like this you give in structure. So in order to make, say, an employee, you make a structure, name, age, like that. So this is structure is just collection of different data types. Class deals with data members and member functions. So in a class you will have data, also the functions operating on that variables. But in a structure we will only have data members, no functions. In the class supports inheritance, that is you can have a parent, that is have a class, and the child can inherit it. That is, a class can inherit the property of some other class. It can inheriting the property means it can gain access to the data variables and the functions if they are public, of course. So this is how we inherit. So it supports inheritance. And the structure does not support inheritance. There is no concept of inheritance in structure. Member variables cannot be initialized directly. In class, you have to go through the object. Everything is object. So you create an object, then you start initializing the member variables. But in structure, the member variables can be initialized directly. Means the structure you can this struct is also a blueprint. But you make the variables, structure variables they are called, and then you start accessing the inside values. See, class is just a type reference. It is a user defined type and it is a reference for the object. And structure is of type value. It's a structure type. So class, its member are private by default. In C++, there are various programming languages like C++, Java, they are object oriented. So the members normally they are private by default. So if you don't write anything before the class function or variable, it is by default a private. For example, this class has run. I haven't written anything in front. That is private object. Structure, the members are by default public. So you have to make it private if you want to. The keyword class defines a class. So you have to write a class. For structure, you use a keyword called struct, struct. Then you can make the structure variable and class variable. So an instance of a class is called an object on which the object oriented programming is based. And the structure, the instance of structure is a structure variable. It's a structure variable. While we are dealing with complex data structure, this is useful. Class is the only thing which we can try useful while dealing with the complex data structure. That is why we are saying the complex projects are handled by C++ or Java or Python and PHP. These structure are useful while dealing with the small data structure like an employee detail, student detail, like this. So the class is a very big concept. Structure is a usage concept. What is the concept of access specifiers? When should we use these? First of all, the access specifiers and access modifiers are same. Just a minor difference. So just assume that this is your house. This is me and this is my friend. I can come in your house, so I am public. You have given me public access. That is, I can access your house. My friend, you haven't given him any access. Now he is private. You are not providing him any access. And public private is, these are access. Access means trying to get some certain thing, try to use certain thing. That is the access. So access specifier in object-oriented programming language is access specifier or access modifiers. These are reserved keyword that is employed or used to set the accessibility for the classes. Inside them we have methods and members. So for methods and members, these access modifiers are used. So we have access modifiers or access specifiers. It includes the public, private and protected. These are keywords. So protected is all about, when you use the inheritance. So these are three access specifier, modifier: public, private, protected. So, there is some other access specifier. They are language specific. Like the Java, there is another access specifier called default. So I am just talking about this code now. We have private, public, private, public. What does it mean? That is, who can access what? If you have protected, only the inheritance class can access. Private, it cannot access. Public, it can access. Public and protected and inherited class can access. But the outside class will not be able to access private. So these access specifier play a vital role. You know, the data abstraction and data hiding all is achieved, all is the implementation is through private, protected and public only. Data abstraction and data hiding is a concept, but private, public, protected, they actually implement it. Okay, so this is the table where we have showed the private in derived class what happens, outside the class what happened, within the same class private, protected, public all are accessed. Derived class only public and protected, outside the class only public. Okay, see here, this is a class, this is the class name. Now there is a variable integer with a private access, there is an employee name with a public access, there is a function with a private access. So all the inside material can be accessed by anyone inside the class. Outside class can only access the public material. The inherit class can only access the public and protected the access specifier variables or the functions. Okay, so this is to, because in object oriented programming language everything is data. So if you don't provide these access specifiers, the idea of data it doesn't happen, because there is no local global here. What are the manipulators in object oriented programming and how it works? See, manipulators, the name itself is showing that it manipulates certain. It manipulates what? It manipulates what to be seen. These manipulators can only be used in input and output statement. For example, printf in C, cout and cin in C++. So we have the manipulators just to how to show it to you. So the manipulators are functions. They are just functions. They are helping functions. So they are used to manipulate or modify the input or output stream. Okay. So the modification is possible using the, in C++ if you are using these insertion and extraction operators, that is these angle operators. The modification of input and output stream does not mean we are changing the value of the variable. Please understand, I just said it is manipulating and modifying the input and output stream. I am not saying it is changing the actual variable value. It is just to show, it is just manipulating and modifying the how to handle, how to show it, not to change it. There are two types of a manipulator, with arguments and without arguments. So as I said, manipulators are used only in input and output statements like endline, fix, show, point, set w, set precision. I'll show you some more of them. These are manipulators which control the output format. Whatever you see on the screen, these are going to manipulate it. Only the screen weight, how much on the left you have to see, right you see, the numbers, how much numbers you want to see, like the end line. End line just terminate that line and takes your cursor to the next line. This is your end line, like your enter button in Word or any text document. So you see here, this set W is set width. So when we say set W8 and we want to print 1, so set W8 means there will be 8 blank spaces, and the rightmost one will be taken by 1. If I am writing 10, 6 places will be blank and 10 will be shown on the right. Similarly 100, on the right we have 100, and then we have other 5 places. If you put set fill, say you put set fill star, these blank spaces, because blank spaces you won't be able to see on the screen. But when you put set fill with star, the blank spaces will be filled by the star. There is one more thing, set precision. There are certain decimal values which are having lot of precision. For example, 135.456, it can be 456989999 like this. You just want to show 5. That is, 3 plus 2 like this. So this is 3 plus 2 means before and after decimal. This is how you do this set precision manipulation. So as I was suggesting, the example of because manipulators can be with arguments and without arguments. So the manipulator which do not have argument are end-l, ws flush. With arguments are set w, set fill, set base, set ios flags. Some other manipulators are also there. They are show pose, the fixed, scientific, hex, dec, oct. What are the rules of creating a constructor? So whenever we are dealing with object-oriented programming, we have a constructor. This is automatically given by the programming language. So whenever we are making a class, this is a template. Class is a user-defined data type, and this is a class called calculation. Now the constructor will be of the same name with the name of the class. So if you see here, this calculation and this function calculation, class name is calculation, the function name is also calculation. So whenever we create an object of this class, say using a new or whichever memory allocation you allot, so when you instantiate a class, then the constructor will be automatically called. The class name and constructor name is same. You get free one of the constructor. It is already always given to you whether you want it or not. One, and that is just to initialize certain variables which you don't want to initialize again and again. But you can make, because this is just a function, so you can make functions. So you can overload this function with respect to the input data types. You can always give as many of the data, the parameters, and you can make any number of constructor. But one constructor, the default constructor will always be given to you. First thing is, constructor does not have a return type, not even void. So constructor has no return type. In all the other functions, you have to give certain return type like integer, like float, etc. But here you don't have to give any kind of return type. First thing is clear. See, if you want to initialize, for example, x and y there, whenever we create an object, I want x as 10, y as 10. So that is why this constructor is used. The basic function of constructor is to initialize the variables whenever you call or you make an object. Okay. You cannot make this constructor as static. You cannot make this constructor as abstract. You cannot override the constructor, that is in inherited class. You cannot make the same function with this name. Means you cannot override this. It cannot be final in C. Final means constant. const. So you cannot make it as constant. These are the rules. What are the differences between the constructor and methods in Java? So in object-oriented programming, we have Java, C++, PHP, and Python. So constructor and methods. Constructor is a method, but method you make. Constructor is already given by the programming language. So the constructor is a function of the class which is already by default given to you. You don't have to make a constructor if you don't want. But method is user defined. You have to make a method with respect to what kind of work you are doing. What functions do you want? So constructor has the same name as the class name. The name of the constructor and the class will be same. For example, I'm making a class, say I'm making add. The name of the class is add. So I am making a function called add. So this can only happen when add is constructor. Okay. Constructor has the exact same name as the class name. Default constructor is already provided to you by default by the class or the object-oriented programming language. But if you want to make more constructor, you can always make more constructor. There is a default constructor, many constructor you can make. But method is like you want to make a set value function. This has no link with constructor. This is just a function which is going to work on the variables you have defined. This is what you want for your class to be performing. Okay. See, the constructor is a special type of method which is used to initialize an object of its class. So whenever you make an object, if you have variables or certain other content here, you always want to initialize these values whenever you create an object, and that is only possible when you have a constructor. Constructor is only provided to you like this. You put x equals y equals 0. So whenever you make an object of this class, this x and y will automatically be 0. Okay, but method is just certain instruction in Java or C++ that you want to execute. That will fulfill the action you want. That is the work you want to do by this class. Okay, this constructor, you can say that it is just related to more to a programming language, and set value or any other function which you make is more related to you as a user. Okay, so constructor is invoked implicitly when we create an object, but for calling this set value, you have to call it explicitly through the object. So these are the constructor is by itself. The default constructor will implicitly be called. The method you have to call by yourself. Now, if you are making one more class and you are inheriting this class, that is called the say a child class, and this is the parent class. The constructor will not be inherited by the subclass. I am talking about Java. Okay, so methods can be inherited by the subclass. Constructor does not have any return type. Method have a return type. In constructor in Java, you cannot override the constructor, but method you can override in Java. And this overriding is all about, if you are inheriting, you are making the same function in a different way. Constructor cannot be declared as static because this is user defined. No, the method is user defined. It can be declared static, but constructor cannot be declared static because it is not you have created. It is the programming language which has given you. Constructor Java compiler automatically provides a default constructor which I have been telling you. Method Java compiler does not provide any method by default. You have to make set value. You have to make get value to get it. How does procedural programming language is different from object-oriented programming language or programming? So the procedural programming, functional programming, or the structured programming, how it is differing from the OOPs? The first thing is that these are the concepts on which the object-oriented programming is based. These are the different, you can say, the basic building block. The procedural or functional programming is all about functions. So we have a main program and it calls different functions, and those functions in turn call different more functions. So it is all about functions. So procedural oriented programming is all about function. It is based on functions. While the object oriented programming, we are talking about real world entity representation, and that can be done using the objects. Okay, because object is coming from where? The blueprint class, and class is representing the real world scenario. So everything is object. In procedural oriented programming, it follows a top down approach. That means you start with main program, then the functions will be called, and then the functions will be called. The object-oriented programming, it follows the bottom-up approach. First, we make the classes, we bind these data variables or data items with the functions, and then we combine the classes, or then we collaborate the classes. And that is how it forms a bottom-up approach. This is a bottom-up approach. Procedural language, the data is not secure. Even it is by itself not secure. because data cannot be hidden. See, in C program, the data can be written when you start from main. So here you write the data. It can be local data, and one more thing you can do is make the global data. So there is no secrecy, there is no privacy, there is no access, access specifier or modifier for that. But since in object-oriented programming we are saying int a, so we can give private, public, protected. That is, the object-oriented programming languages, they provide more security. That is, the data, the whole thing is around data only. So here the procedural oriented data is visible to the whole program. As I said, you just have to declare, even in C you have to declare it above any instruction where it is using. So data is visible to the whole program, whole functions. But object oriented programming, the data is encapsulated inside a class. There is a proper capsule which is called as a class, and it contains the data members and the functions which are operating. So this is, I'm making a capsule here. In procedural, the reuse is not that much possible, though you can say the function can be reused, but in totality you have to write more codes rather than what you are doing in object oriented, because here you are making a class, then you make another class, and if you want to use the class A content, the first class content, what do? You just inherit that class. So that is, the inheritance is providing you the reusability. This is how the code can be reused. You don't, the kiloline of codes or the instructions, number of delivered instructions, they are less as compared to the procedural. In procedural, the modification and extension of code is not that easy, because you have to go to different functions, see where the function is being called, and then you do the modification. In object oriented, because you have different class and everything is bound, you know very clear cut structure. Now you can easily modify and extend the code. If you want to extend code, if you have 10 classes, you know which class you are going to go. You can extend the code there. In procedural, the examples are the C, Visual Basic, the Formula Translation or Fortran, the Pascal. In object oriented, we have C++, Java, C#, and then we have the PHP and Python. They are also object oriented. PHP is for web, for server side programming. What are the differences between error and exception? So we will take the example of Java here. First, let me tell you here, they both belong to throwable class. So error and exception, but error should not be caught. You know, there are certain irrecoverable errors, but exceptions you can catch. You know it already. So error is error. You know, in any program, that even if it is procedural or any other, the errors are error. So they should not be caught. They could be declared, but they are irrecoverable. Now we are talking about exceptions. Exceptions we need to catch it. So you need to be catching it. So should be caught. It could be declared, and they all are recoverable errors. So recoverable errors are nothing but exception. You know about the error now. So recoverable errors are exception. So they both belong to this throwable, right? You see the hierarchy. Okay, coming to the recoverable and irrecoverable. So exception can be recovered by using the try catch block. We write the try catch block inside try. If something happens, then you catch it. So, and you know how to catch it. There are all the scenarios if you actually go to the programming. The error cannot be recovered. The error has happened, it has happened. In terms of type, the exception, it can be classified into two categories, checked and unchecked. But in error, all errors in Java are unchecked. All errors in Java are unchecked, but the exceptions, they can be checked, they can also be unchecked. the occurrence, the exception or can occur any time. It can occur in compile time or runtime. But the error will always happen, it will always occur at the runtime. Exception. Now there are packages. It belongs to this package is java.lang.exception package. So if you are not from Java, then you can just skip this. Error, it belongs to java.lang.error package. Exception, they are known or unknown. That is, exception, only checked exceptions are known to the compiler. Only checked exceptions. The errors will not be known to the compiler. Will not be known to the compiler. But the exceptions, the checked one are known to the compiler. Exception, it is mainly caused by the application itself. For example, the null pointer, array out of index, arithmetic exception. But error, it is mostly created by the environment in which your software or the application or the program is running. For example, the exception, you can have checked exception like SQL exception, IO exception. We have other exceptions like array out index out of bound exception. For example, your array is 100 and you can access 0 to 99. You have started accessing 100. That will be array index out of bound. In the error, we have java.lang.stack overflow, java.lang.out of memory error. That is the stack and memory problem is there. What are the characteristics of an abstract class? An abstract class. See, this is the core. In any programming language, especially in the object-oriented programming language, the abstract classes have to be implemented. You cannot instantiate it. You cannot make object of it. That is the inheritance defeats all the concept of objects. But abstract class, it is the basic concept of object-oriented programming. So abstract class is a class that is declared as abstract. So you have to put the keyword. So it cannot be instantiated. That means you cannot make an object for this abstract class. That is, I'm making a class and say the class is A. And now this class A, I can make the object of this class, right? Inside main A, I can do obj1 or like that. So I can make an object for any class. Abstract, we cannot make the object. Object cannot be made. Because why to make the object? The abstract class has no implementation. It is just telling you that I am there. You have to implement me. You have to execute me. Means you have to put the code inside your derived class. So that is how inheritance becomes better there. So here you see the abstract. This is the keyword. So this shape class is an abstract class. And inside that we have two abstract. Right? We have two abstract. And there are two functions which are defined as abstract, which is area and toString. So this abstract class should have at least one abstract function. That also I am going to tell you. But the main thing is, when you make the derived classes, then the thing comes that you are not going away from the object-oriented paradigm, because now you just have the template and now you have to implement whatever is given in the abstract class. There is no function definition. I'll tell you one more thing. This is about Java. So we have, when you write a class can have any name, but the type should be abstract in order to make an abstract class. So you have to use the modifier abstract on a class header to declare an abstract class. The abstract class is a placeholder in a class hierarchy that represents a generic concept, and you have to implement that concept. Okay. Whichever class is inheriting, for example, we have an add function inside this vehicle. So that class which is inheriting should implement this add. There will be no implementation of add in the abstract. You have to do it when you inherit it. I hope you got the idea. So you just tell what needs to be done. You don't tell how to be done. That is done by the derived class. So instantiation cannot be done. it must be inherited. The abstract class has to be inherited. The abstract class can have both abstract and non-abstract method. If you see here, we have two abstract methods and one data member, and this. And as I said, you must declare at least one abstract class in the abstract class to make an abstract. It is always public. Why it is being made? So that it can be inherited. So it will always be public. It is declared using the abstract. So the purpose of the abstract class is to provide a common definition of the base class that multiple derived class can share. Okay. So this is all about a template, a generic class, a generic concept, and this is a good inheritance, and it does not go away, or it does not, we can say, bog down the whole purpose of the object-oriented programming language, right? So abstract class is a very powerful thing, and I just encourage you to always use the abstract class. So now this add, if two classes are say inheriting, one can write some other implementation like I'm showing. I'm just giving you a very vague example. So every class which is deriving can have different implementation. This is possible for a class to inherit the constructor of its base class. Is it possible? I'm talking about Java perspective. No. A class cannot inherit the constructor of its base class. This is about Java. There is a scenario, very interesting scenario. Now what happens here? Now you have to, there are 5 friends. There are 5 friends and they're good friends, and they go out for some food and beverages, etc. But one of the boy in these 5 boys, he never gives money. He is never contributing at all. The 4 other guys are contributing. Now a beautiful, very, very good looking, beautiful girls come in this group. Now the boy who is not contributing, he started contributing. He is now spending a lot of money in this group. So you have to identify which OOPS concept should be used in the following scenario. You have seen, I have already given in the pictures. The answer is runtime polymorphism. Runtime polymorphism. So runtime polymorphism is, you can say that it is the late binding. That is, it is not a compile time or early binding. It is the late binding that we need to implement it using the virtual function. It is also called as we implement it using the function overriding. So I'll give you an example also. But one thing is, never gave money, but when the girl came, he was so excited. On the runtime, he started paying money. So let me tell you again, runtime polymorphism. Whenever an object is bound with the functionality not at the compile time but at the runtime, when you actually run the program, it goes to the processor, then this runtime polymorphism takes place. So the runtime polymorphism can be achieved by what I just suggested you, method overriding. And method overriding, what you have to use are you have to use the virtual functions. Method overriding is that already a method is defined, the other method is also defined, same name, which needs to be called, the base class or the derived class. So in order to call the function of the derived class, you have to use the virtual function, because ultimately it is going to call the base class only, the function of the base class always. So you need to do the method overriding, that is, you want to execute your function inside the derived class. Let me give you an example. This is the base class. This is the derived class. Now you see, both the classes have getData function. But the second class, which is the derived class, is derived from the base class. This is the base class. You have a function getData. This is a derived class. That is, derived class is derived from the base class. Same function, same name, everything is same. So now the implementation is different. That is, whenever I want to call derived obj, that is I'm making an object and I'm calling obj.getData, what is going to be called? This will be called getData. This base class will be called. For that you have to put, what you have to do? You have to put virtual in the derived class. That is, you have to make the function getData as virtual. I hope you are getting my point. If you do this obj.getData, the getData of base will be called. In order to call the derived one, you have to put a virtual. What is composition? Now, composition is somewhat of the advanced level object-oriented programming concept. So now you made a class, say class A, okay, and you made an object, say obj, wherever, main or wherever. Now you made a class B, and now what you are doing? You are taking the object of class A and putting it in your class B. So you are taking the object of class A or using the class A or referring the class A object as the variable. Say I am making class C also, I am making object 2. So class B is having object 1 and object 2, one from the A class, one from the C class. So this is the composition, has a relationship. See, Honda has a car engine. See, inheritance is also important here, and the composition is also important here, because when you are extending, a car can be Honda, a car can be Ford. So Honda is extending the car, or you can say Honda is derived from car, but has a relationship or a composition relationship is all about referring the objects of other class and using them or putting them inside your class as the variable data members. So the class B has A, class B has C, like a Honda has a car engine, a Ford has a car engine. So in Honda, you are taking, in Honda class, you are putting the object of car engine class. So it describes a class that references one or more objects of other class in instance variable. So it models has an association between objects. So we can see these, as I just told you, in real world we have this Honda and car engine kind of situation will always arise. So class B has A, class B has A, and class B has C also. I have not made the class C, but just imagine. So this is the whole scenario we are discussing. This is the composition. Normally to the beginners it won't be asked, but for the advanced or experienced C++ guys or the object-oriented programming guys, this composition is a very important concept. And this will always be asked if you are going for an experience interview. Now, if you want to change the benefits of composition is reusing the existing code, designing clean APIs, changing the implementation of class used in composition without adapting to any external clients. What are the differences between copy constructor and assignment operator? Assignment operator is just an operator, but we are talking about when this assignment operator is overloaded or it is used in terms of with reference to the constructor. Now this is a very very easy concept, but need to be understood. I'm giving just an example. We have a class name. I made a class, two objects. obj1, obj2 are the two objects of class, some class. Now object 1 equals object 2, so we have assigned obj2 to obj1. So object 2 has been assigned to object 1. Now let us take one more example. Now this is of the copy constructor. See, we have a class, let us name it as sample. Now you have a constructor here. What you are doing is you are taking a and b value, initializing it to I and j. That is the work of the default constructor. It takes the value and just initialize it to I or j, which are the member variables of the class. The copy constructor is, you have the class name. Again, inside you have the class name. That is, you are making class name. That is, you are actually making an object. So you are passing the reference, that is S, inside the sample. Okay, so you are copying this is a copy constructor. So actually what you are doing is, you are taking this content of above constructor and putting it inside some other constructor. That is, whatever you got in ij, now you are putting this si and sj into this ing. So you are copy. This is the copy constructor working. So it is. I'll tell you the other way also how it is done. This is the actual way how it is seen. So the copy constructor and the assignment, they both are used to initialize one object using another object. The main difference is that between the two is that the copy constructor allocates separate memory to both objects, the existing object and the newly created object, while the assignment operator does not allocate new memory for the newly created object. So if you can see here, I'm making two memory location. So we have two memory location for these two constructors which are being made using the copy constructor. So we have copied one constructor into another constructor. But here we have obj1, obj2, they are pointing to the same memory location. This is just a reference. There is all one object. Object 2 was already having a memory. Just imagine object 2 was already initialized. So object 1 is now only pointing to the location of object 2. Now see one by one. First of all, the copy constructor is an overloaded constructor. Assignment operator, it is just an operator. Copy constructor, it creates a new object as a copy of an existing object. So this is the existing and this you have copied it. The assignment operator, it assigns the value of one object to another object, both of which already exist. Obj1, obj2 already created, they already exist. But copy constructor, while copy constructor, they're actually making a new constructor, and also in the same time we are assigning the previous constructor content to this constructor. Okay. You can also say like this. Now let me show you another way. This is A and B, they are both constructors. So B bracket A, this is also the way you can do. So you are putting the value of A constructor into a new constructor which is B. This is the copy constructor. Both the objects one by one. See, when the copy constructor is used when a new object is created with some existing object. This is very important. So I told you already one more thing. Both the objects in the copy constructor, they use separate memory locations. But here in assignment operator, both objects share the same memory, but use the two different reference variable that points to the same location. Copy constructor. If no copy constructor is defined, the compiler will provide you one. It is already there with you. Assignment operator is not overloaded. If it is not overloaded, then the bitwise copy will be made. As I said, this object can only be assigned when this operator is your overloaded operator. What is polymorphism? Polymorphism, there are two words here. This is a Latin word. So it has come from poly and morph. Poly means many, morph means shape. For example, if I tell you a word, write, you can write it like WRITE, or even you can understand RIGHT. Generally speaking, when we are talking about the programming paradigm, the polymorphism means that a method or function is able to cope up with different types of input. So polymorphism is the ability of the message to be displayed in more than one form, depending upon the situation, depending upon the scenario, depending upon the invocation. So in C++, polymorphism means that a call to a member function will cause a different function to be executed depending upon the type of object that is calling that function or invoking that function. So polymorphism can be of two types. It can be a compile time polymorphism. It can be a runtime polymorphism. The compile time polymorphism is implemented in two ways. Let me tell you, compile time is early binding, runtime is late binding. So in order to implement the compile time, we have function overloading and operator overloading. Similarly, for late binding or runtime, the method overriding is done, and this is implemented using the virtual functions. So this is, I am telling you about the compile time. So we have a class here which is called figure. Now we have three functions here. Now these functions, this class object is being made geo, and this geo.area, 3 times this area is being called. Now the name of the function is same. This is called polymorphism. That is, name is same, but depending upon the input. If you give 7.0, it is going to call this middle function. When you pass 2,3, that is integer, it will call the first area function defined in the class. And when you call third area, that is going to call the third function in the class, which is having two double values as the input. What are types of polymorphism? Example of runtime and compile time polymorphism. First thing is, polymorphism is what? One phase different acting. That is, one word or one function doing different work, performing different work depending upon the invocation or depending upon the calling or scenario. Polymorphism has come from two words, poly and morph. Poly means many, morph means the faces or shapes. So it can be of two types, compile time and runtime. Compile time is also called as the early binding. Runtime is also called the late binding. The compile time or polymorphism is implemented by function overloading and operator overloading. The late binding runtime is implemented through virtual functions. So I'll give an example of that. First of all, the compile time polymorphism we are taking. This is the example of function overloading. Now we have a class here. The class name is figure. We have declared and defined three functions here, and they have the same name. This is very important. Same name. Inside main, we have created an object of this figure class, which is called geo. Now this geo is invoking the function, but it is invoking same function, area. The names are same. But depending upon the input type, the parameter type, the object is calling different functions, and this is called the compile time or early binding. This is an example of function overloading. Depending upon the different situation, it is behaving differently. Function is. Now taking an example of runtime or late binding, this is virtual function. For this, we need inheritance. This can only be possible when you have an inheritance kind of situation. Okay. Inheritance says you have a base class. Now this base class has a function called print. Similarly, we have a derived function, and the function has also print. But this derived class is derived from where? From the base class. That is, derived class is inheriting the base class. So we have a derived class, and this derived class is inheriting the base. So this is a relationship. So derived is a base. Okay. Now both of them have a print function. Same function, nothing, no difference. Same function. Now when we create an object of this derived class, we pass a reference of this derived object to the base pointer, and from base pointer we are calling the print function. What should happen? To be very honest, it should call the derived class, the print function, from what we see here. But the situation or the problem is, it will not call the derived print function. There will be an error. That is, why we have done this ampersand derived? Because we have passed it to the base, and then base is calling the print. So we have actually tried to call the derived function, the print function of the derived class, but this won't happen. For that, You need to do what? You want to force that whenever I do this, I want to call the print function of the derived class. Actually, it is coming from the base class. The base class is always giving that function from this kind of code. Okay. The solution is, what is the solution? The solution is, if we want to get the derived function, the same name, please remember the names are same. Then we have to write virtual. Give a real world example of polymorphism. Polymorphism is one phase, different acting. One thing doing different kind of work. So general meaning of polymorphism is one that have different forms. Just assume a person playing different roles. A person at home can be a father, can be a husband, can be a son. So different role he is playing, single person. The same person, when he is in office, he is acting like boss or an employee. When he is traveling in train or public transport, he is a passenger. When he is in hospital, he is a patient or a doctor. In a shop, he is actually a customer. So a single person is behaving, is acting, is playing all the roles whenever the situation demands, whenever this situation arises. The person, they see, just assume that this role is a function or a method. So this person is playing different role as a father, role as an employee, role as a husband. So same role, this role function will be connected to employee, father or husband depending upon where he is. Is he in the office? Is he in the house? Or is he in the public transport? So same person possesses different behavior in different situation, and this is a very good example of polymorphism. Now we have a class here, class name is figure. Now we have three functions, same name. There is no change. This is very important in polymorphism. The name are same. But when we make the object of this class, which is called geo, and we are calling area, the names are same, area. Now, which is going to be called? Which function is going to be called? And this will be decided in the compile time, that whenever you pass the integer, it will go to the first function. Last, both double, it will go to the third function. What is the difference between composition and inheritance? Now, see, inheritance means what? Inheritance is all about reusability. It is a relationship. That is, a house is a building, or you can say building is a house. There is both a relationship. But just assume that something is a bigger set and something is a smaller set. So, if I am the son, I inherited the property of my father or money of my father, then I am inheriting. So my father is my base class and I am the derived class. So derived always is extended from base. Base is the base class. So derived class will inherit base. Also, it can provide its own function data variables. This is the inheritance. Now coming to composition. Composition, let us understand with an example. We have a class A, then we are making a class B. Now we have a class C, and we have an object of class A. We can make a class an object, that is A obj1, and we can make an object of class B also, B object 2 obj2. But now you see, these two objects of two classes are the member variable of class C. So now class C has A, class C has B. When a class is referring to other class with respect to their objects, it is called a has a relationship. Okay. So inheritance is a relationship, composition has a relationship. Composition means that an object holds other object. Inheritance, there is only one object in memory, that is a derived object, whereas in composition, the parent object holds references to all composed objects. For example, take car and an engine and Honda. Now, Honda is a car. Honda is a car. So Honda is the derived class, car is the base class. Okay, so Honda is drive class, car is base class. The car has an engine. Car has an engine. Every car has an engine. So this is a has a relationship. This is the difference between composition and inheritance. So the inheritance is all about inheriting, or say base and child relationship, but the composition is referring to other class with taking their objects. So class Honda, you can say class Honda colon car. So class Honda is a car. So this is the inheritance relationship. What is constructor chaining? So one constructor calling another constructor, in turn that constructor is called another constructor. So chain is what? Chain is like this. One is connected to another, the other is connected to another, like this. This goes around and on. So constructor chaining is when the constructor calling goes on and on. So in object-oriented programming, constructor chaining is a sequence of invoking constructors or calling constructors of the same class upon initializing an object. When you initialize the object, number of constructors are getting called one by one. It is used when we want to invoke number of constructors, one after the other, by using only one instance. That is, when we are making an object, we are not interested in calling constructors one by one. We are just saying that let me call one constructor and let that constructor call the other constructor one by one. So if a class has more than one constructor that is overloaded and one of them tries to invoke another constructor, this process is known as constructor chaining. In C++, it is known as one more name is there. It is called as constructor delegation. Constructor chaining is also called constructor delegation. It is present in C++ from C++ 11. Okay, take an example. Here we have a class called student, and since we have three constructor here, you can just recall that the name of the constructor and the class will be same. So now this is a default constructor, nothing is given here. Now we have a constructor, we have this is a, you can say we have defined it. So you have an input which is string, and now we have this here, this call itself. Okay, now we have another constructor which has one string, one integer. Again we have this here. So whenever we create an object, we have created an object here, student. So we have created an object of our class, and we have passed two parameters, one is string, one is integer. So where it is going to go? It is going to call the constructor by itself. New operator will definitely call a constructor. So this will be called. All the work will be done, all the instruction will be executed, but the last is this name. So this means it is going to call the constructor, but what is the parameter? Name, string. So it is going to call the constructor which is shown just above, this one. Now again the instruction will be executed. Now at the last we have this. So it is going to call constructor with no parameter. So it is going to call default constructor. So this is how the chain is formed, and chain of constructor is formed. That is why it is called as constructor chaining or constructor delegation. What are the limitations of inheritance? See, inheritance is all about reusability. So we have a class, two classes. Class B is inherited from class A. So class B is inheriting class A, right? That is, class B is a son, class A is a father. So son is inheriting the property of father. So see here, multi-level is there. Class B is inherited from A and class is inherited from B. So here hierarchical, class B and class C both are inheriting class A. That is, they both are taking the properties of class A. Properties means data function members which are protected or public. So this is the inheritance. But what are the limitations? This is a very reusable. RY I have written for reusability. This is a very good example of reusability. But the disadvantage of using inheritance is that two classes are now tightly coupled. One is dependent on another. That means one cannot be used independently of other. When you talk about design, what do you want? You want low to low coupling. You want high to high cohesion. So when we talk about two class, we talk about the coupling. So if a method or aggregate is deleted in the superclass, we have to refactor using the method in the subclass. That is, class B is inheriting class A and it is taking all the function and data variables which are public and protected. But what happens if class A is deleted? Class B, you have to refactor it. Or what happens when the function of class A is deleted? That function has to be refactored in class B. And inherited functions work slower compared to normal function. Normal function is just like that. Here we have to first there are different levels of control flow. So the control flow or the control, you can say passing is too high here. So we need to be very careful about implementation. Otherwise, it will have improper solution. So we cannot change implementation inherited from plain class at runtime. This is the disadvantage. And parent class often define at least part of their subclass implementation. There is always some part. So what is encapsulation? Encapsulation is having the code and function together. So when you are inheriting, you are actually going away from the object-oriented paradigm, because inheritance is what? Inheritance is taking the code and function of the above class. When you're taking you can access code and function of other class. What is about the encapsulation? So the best is to make an abstract class. Don't give any kind of implementation here. Just give the definition and implement that function. Implement that function in your derived class. What are the differences between inheritance and polymorphism? See, they both are the basic building block of object-oriented paradigm. These are the concepts and object-oriented programming languages they implemented using different constructs. So, let us take one by one example or differences. First is inheritance is that concept in which a derived class inherits the already existing class. For example, a class A is having data and function. Class B is inheriting class A. That means it is inheriting data and function of class A. So you can say that class B has class A inside it. Okay. See here also multi-level. A is inheriting B is inheriting C is inheriting B is inheriting A. So now C has A and B both. Polymorphism is that one name and different word, one function acting and performing in different scenario in a different way. So polymorphism is one that you can define in different forms. A person can play a different role. So depending upon the parameter in this function role, it can be a father, it can be a husband, it can be an employee. Depending upon what are the parameters you are giving inside this role function. So it will play a different role. The function will remain same. It will be a role only. Polymorphism, let me tell you that we have two types of polymorphism, runtime polymorphism and compile time. This I just told you about the compile time. Runtime, you have to do the virtual function kind of thing. And that is only possible when the inheritance scenario is there. Okay. Inheritance, it refers to using the structure and behavior of a superclass in a subclass. I just told you when we inherit, that is when you inherit your father's property, you have all the property. So you are actually having his property in your pocket. So the polymorphism, it refers to changing the behavior of a superclass in the subclass. That is, polymorphism is all about changing your word depending upon the scenario. For example, you are making a class here. Okay. Now class B, and now you have inherited class A. So now you have a function, say fun and fun both have function fun. Now when you write a main function and going to call, it will always be calling normally the base function, that is the base class function. If the function name are same, so you have to make this function as virtual. not the virtual class, I'm saying virtual function you have to write. Then only the derived class function can be accessed. So this is called runtime polymorphism. And this runtime polymorphism is achieved by method overriding. That is why we have the implementation of this fun function in your derived class. Okay, inheritance. It is required in order to achieve polymorphism. As I just told you the example, that polymorphism is only possible when there is an inheritance scenario. And polymorphism, in order to achieve polymorphism, inheritance is not required, for example. Okay, inheritance is applied to classes. See, inheritance is applied to classes. We are talking about two different classes. But what about polymorphism? Polymorphism is applied to functions and method. So inheritance, it can be single, hybrid, multiple, hierarchical, multi-path, and multi-level inheritance. There can be different type of inheritance. What about this is different kind of multi-level. I'm just explaining you. We have hierarchical also. So polymorphism, there are two types of polymorphism. Just now I discussed. This is the runtime and the compile time. So runtime and compile time. It is runtime is also called as the late binding. Compile time is also called as the early binding. So compile time, you can implement it using function overloading or operator overloading. Runtime is method overriding. Inheritance, it supports the code usability and reduces the line of code, because it is all about that. You are inheriting the code, so you don't have to write that code again. When class A is inside class B, and in the multi-level the class A and B is inside class C, that means you are actually taking the code. So the kilo line of code will be less. In polymorphism, it allows the object to decide which form of the function to be invoked at runtime, that is overriding, and compile time, which I just told you about, overloading, operator overloading, or the function overloading. So depending upon the scenario, the function will be called, and depending upon whether you are using virtual function, the base class or the derived class function will be called. What is coupling in object-oriented programming and why it is helpful? Now let me tell you about an example here. This is a class A. Just assume that all these functions are related to email. Check email, validate email, send email, like this. All functions are related to email. Now this is so good. Class A functions are like-minded. They are doing the work they are supposed to do. They are only working for the case of email. They are doing nothing else. This is called a good cohesion, a tight cohesion. But now somebody does like this. Class A, he wrote check email function here. In class B, he wrote validate email. Now the problem is, when I create the object of class A and object of class B and object of class C, now for example, if I'm saying object 3, I want to send email. Just assume that before that it has to be validated. So object 2 and object 3 became very close. So the object 2 and object 3 can change one another behavior. So that this is the object can directly change the state and behavior of object. So here left you see high cohesion. Here we have low cohesion and more coupling, tight coupling. And this tight coupling is not advisable. Cohesion should be high. Cohesion is only about a module or a class, but coupling is between two module or two class. So if the objects are closely coordinated, they are changing themselves, they are interacting, they are message passing, then the coupling is too high. But the cohesion should be high, and coupling should be low. Let me tell you again. If there are two objects or two different classes, and when they are interacting too much, they are changing their behavior of another, that is called high coupling, which is not, or tight coupling, which is not required. This is more dependency, more coordination, more information flow. We don't want that. We want loose coupling, less interdependency, less coordination, less information flow. So coupling is this. And how it is helpful, I told you about that. name the operator that cannot be overloaded. So which are these? See, there are only 5 in C++. I'm talking about C++ 11. Okay. So we have scope resolution operator, two colon. Then we have ternary operator like question mark and a colon. Then we have a member access or dot operator, which is dot. Point to member operator, that is this dot star, and size of operator. These C++ operator that cannot be overloaded and other which can be overloaded are given here in this table. What is cohesion in object-oriented programming? Now let me give an example here. See, this is a class. Just assume that this class is doing everything related to email. All these functions, check email, validate email, send email, and all others, they are working only for email. So now these functions are closely related. They are like-minded. They are doing only the work for email. That is, this particular class has high cohesion, very good cohesion. And that is what we want. We want a module or a class to have high cohesion. Everything should do think together and for a single goal, like single-mindedness. Now what happens? Somebody did something differently. He made a class A and placed check email. He made another class for validate email and another class where he put this send email. Now you see, when if somebody wants to send mail, or the mail class has to be accessed. Previously, class A was very good. But now when we have different classes having different functions of mail, when we make the object, these objects are going to interact. They are going to collaborate. They are going to be interdependent. And that is not good. Now this is called coupling. When we talk about two different classes, the interaction collaboration is the coupling. The information flow is coupling. So coupling is high and we don't want that. So we want the coupling to be as less as possible, as low as possible, and the cohesion within a single class should be very high. So cohesion is the property of a module of a class. It is not talking about more than one class. Coupling is minimum of two class, of two objects or two modules. So cohesion, as I said, cohesion refers to the degree to which elements inside a module belong together. They are single-minded. They are working together for a single task. They are designed and made to do a single work or the work which the class wants to do. Okay, and different classes means different responsibility, different roles. So every class should have its own single role. But when we talk about inside the class, all the function data variable, they are highly working together. So we say they are highly cohesive. But when we talk about two different modules, two different class, two different objects, when they are talking together in a very high manner, that is, they are collaborating, they are messaging, they are changing behavior in state, that is, the coupling is high, that we don't want. We want as less as coupling. But if two objects or two modules, they are not passing anything, or they are just sometimes they are interacting, then this is low coupling, and that's what we want. Okay, so this line which I'm showing is a coupling line. How high this line is, that is, the design is not good. And coupling should be as less as possible. And cohesion, high cohesion is associated with robustness, reliability, understandability. Low cohesion, that is difficulty to maintain, to test, to reuse, to understand. So high cohesion often associate with loose coupling. Explain overloading and overriding with example. Now let me tell you that in Java, there are some basic building paradigm concepts. Polymorphism is also one of them. So polymorphism means many shapes or many roles or many work, many function. So for example, if I have a function add, now this is one function. Now if I make multiple function with the same name add, And in a class, I can make the same function, name will be same, only the difference will be the parameters which will be coming inside and also the return type. So this is the overloading. So whenever we will make the object of the class, then that function, that add will be called, which corresponds to the input type and the output type. This is the compile time overloading. Now you see here an example. Now we have a class called sum. We have multiple, actually 4 add functions. So whenever we are making the object, say we are making an object obj1. So whenever it will call the add, now the parameter will be say 2, 3, which will be called? This will be called. Similarly, with multiple inputs corresponding to which the function is matching, that will be called. This is called compile time polymorphism. Let me tell you about C++ and other languages also. We have polymorphism, compile time and runtime. The compile time can be implemented using the function overloading and the operator overloading. So this is an example of function overloading. While in runtime polymorphism, in the C++, we use virtual functions for method overriding. Now coming to overriding. Overriding is runtime. That is the kind of polymorphism where we have the base class and the derived class, and they both have same name function. That is, let me give you an example here. Now this whole class, and please remember in this runtime, the inheritance is important, because without inheritance, this concept we will not be able to discuss, will not be discussing at all. So there has to be some inheritance, and those two classes, base class and the derived class, should have the same function. So which will be called? So we have a dog class here, and we have a function bar. Then we are making a class hound, which is extending that dog class, and here we have a function called sniff. This is a local function, or only to this class it has, but we have bar function also. So this is from the base class, and this same function, exactly same, only the inside will be, I'm talking about the first line, or you can say the signature of the function are same. Now whenever we are making the hound object, and now we are calling the bark function, which is going to be called, this is going to be called, okay, it is going to be called from the hound class. So depending upon which object you are using, that is the base class object, we will call the base class bark. The derived class object will call the derived class bark, and this is the overriding, runtime polymorphism. So in C++ runtime method overriding, this is implemented by the virtual function. So the base class, the function will always be called in C++, so you have to make that function virtual, then the derived class function will be called. What is the difference between a base class and a superclass? See, here we have a base class, and the class which is inheriting this is called the subclass. So this is your father above one, and you are the son below one. Now your father gives all the money and the property to you. This happens normally. So you are inheriting his property. You are inheriting his money. So your father is the base class, or the superclass, or the parent class. Of course, he is a parent. And you are the subclass, derived class, and child class. You will have your money. You will also have your father's money. So there is a possibility of this kind of stuff. We call it as reusability, and inheritance is represented like this. That is, inheritance just means that the base class content, whichever is public and protected, will be coming inside the subclass. The subclass don't have to write this functions and data variable of the base class, it will automatically inherit when it extends, or it will, when it inherits or extends, whichever way you say, it will get all the content from there, not the private one. So this is the base class, is the root class. This is a more generalized class. All these three content is coming here. So 3 plus 3, 6 will be coming in the subclass. So we are talking about now the C++. You have to understand C++, Java, because they both are object-oriented programming languages. So we have the class, base class. It is helping to derive or create a new classes. The derived class, the class created or derived from the already existing class. Okay. The above one is called as the parent class, superclass. The below one we call it as child class or subclass. See, base class, the base class cannot inherit the properties and method of the derived class. But the derived class, why it is called derived class? Because it is inheriting the properties and method of the base class. The inverse is not possible. Okay. What is data abstraction and how can we achieve data abstraction? So data abstraction is a very important feature of object-oriented programming. See, you have a car. Now, when you go inside the car, from outside also, you will use key or you will use your remote to start the car. See, you don't need to know what engine your car has or what air filter your car has. That is the clutch plate you don't want to know, because what is inside is not important to you. The important thing for you is that you can drive the car and you know the traffic rules. That is only important. So the data abstraction is all about showing only the essential data or information to the user and hiding all the implementation details from the user, because it is not required to him. It is not that he wants it. He will not require it. So there are two ways to achieve the data abstraction. We make the abstract class and we make the abstract method. So in Java, if you see, we make the abstract class. So we have the function here. We can make it as the abstract class employee. When this is the class employee, we can make it as abstract. Now this function here has to be implemented by class. Also this Java also has interfaces. So basic thing is, in C++ or any object oriented, the abstract class cannot be instantiated. It can only be used to implement. That is, there will be no function definition in the abstract class. Only it has function definitions. What are the levels of data abstraction? Now this is a part of object oriented programming, but mostly it is talked about in database management system, DBMS. So in the data abstraction, there are a number of levels. It depends all about data or the options or the functionality which are available to the user. So we start with the physical level, that is the lowest level. This is how the database or the content or implementation is actually in the memory. So the logical level, this includes the information that is actually stored in the database in the form of the tables. What are the relationship among the table? So the information available to the user at the view level is unknown. Now view level, this is the highest level of data abstraction. The actual database is visible to the user. It exists to ease the availability or of the database by the individual user so that he can act upon it, he can work upon it. But logical level, physical level is not exposed to the user. Why it is? How it is shown in the memory? Why somebody needs it? Okay. So this is very important. Data abstraction is all about showing whatever is required. What are the types of variables in object-oriented programming? So we'll take the example of Java here. The main variable types here in Java is instance variable, class or static variable, and then we have the local variable. Now, what all are these? See, the instance variable. Now we have a class here. Inside this, we have certain data members, or you can say variables, and one function also. Now, the instance variable, these are declared inside the class but outside the method. So number of objects you will make, this instance variable which is int b here, the number of objects, the number of instance variable will be created for each object. Okay, it is declared inside the class but outside the method. Coming to the static class or static variable. Now you have declared it, just placed a static word or keyword in front. Now when you make the 10 objects of this class, there will be 10 instance variable created. For each object there will be one instance variable. But the static variable only has a difference, that for all these 10 objects only one static variable or static memory will be allocated. Okay, all 10 objects can work on this static variable. So only one variable memory is created. Okay, local variable. Now we are now inside the function. Class will have data members or they will have function. So the variable which is defined inside or declared inside the method or a constructor, because you can have a constructor also. So it is declared inside the method or constructor. These kind of variables are called as local variable. Okay, instance variable, class of static variable, and local variable. Now let us see the more exemplified version. That is, the instance variable, the lifetime is until the object is available in the memory. Now what is the scope? Throughout this class it will have. That is why it is instance variable or a class variable, you can say. Now coming to class variable. The class variable we are talking about static variable. The static variable will be till the end of the program. And what is the scope? Throughout the class. Instance variable only till the object is there. If you destruct the object, the lifetime will be over. Okay. The local variable until the control leaves the block in which it is declared. And what is the scope? Within the block in which it is declared. Within this function func, it will be there. Lifetime, just go out of the braces, it will go. Is it possible to overload a constructor? Now, this is a tricky question. The answer is yes. The constructor can be overloaded by changing the number of arguments, that is the parameters type and the return type. Just change the parameter, integer, float, different kind of version you can make a constructor. As the function overloading is possible, the constructor overloading is possible, because ultimately constructor is also a function. It will behave like a function. So this is the class called demo. This is also demo. So apparently it is also your constructor. Similarly, you have three constructors here. First one has no parameters. It has a parameter string, and this has a parameter double. These are formal parameters. So you can overload a constructor. Now, can we overload main method in Java? Also give an example. From also given example, you might have understood, yes, we can overload it. Okay. So now let us see how it is overloaded. The answer is yes. We can overload a main method also in Java. Any number of main methods you can define in a class, but only the signature, the method signature, that is the name, the input parameters, and the output type should be different. So I'll just give you a code. I'll show you a code how it can be done. We can have multiple main methods. So overloading of main method is possible in Java. So we have here a main function here and second a main function here. Only the signature. See, here we have an integer variable. Here we have a string args, that is the an array. So we can overload it. Overloading is just one name, different word, different role. Now let us see a scenario. Class demo is there. It has a static block and also a main method. Both are having certain printing command or printing instruction. Static block, the static will print, and main will print the static method. Now the question is, which one will first execute? The static block or the main method, and why? The answer is it main? No, it will be static. The Java virtual machine first execute the static block on a priority basis. This means Java first goes to the static block even before it looks for the main method in the program. After that, the main method will be executed. So first static, then main. Okay, this is all about the discussion. Thank you so much. Take care of yourself.